Everyone has heard the sound, that ripping, tearing noise that soldiers described as canvas being torn apart by something mechanical and merciless. Not a bang, not a crack, a buzzsaw, a sound so fast, so continuous, that the human brain couldn't process individual shots. It just registered one long, horrifying note of destruction. Allied soldiers who survived the war never forgot it. Veterans of Normandy, veterans of North Africa, veterans of the Eastern Front all described the same thing in different words. The moment they heard that sound, something changed in their chest. Something primal took over. Because that sound meant one thing: a German machine gun was firing. And if you were in its path, the math was already working against you. This is not a story about statistics. It is not a dry technical breakdown of firearms engineering. This is the story of the weapons that defined how World War II was actually fought on the ground, at the squad level, in the dirt, in the snow, in the rubble. The weapons that forced entire armies to change their tactics, rethink their formations, and develop entirely new ways of crossing open ground. These were not just guns. They were force multipliers that gave a handful of German soldiers the ability to stop entire platoons in their tracks. We are going to go through every major German machine gun used in World War II, from the ones that history barely remembers to the ones that became legends, and we are going to rank them by the one factor that mattered most to the men who faced them: rate of fire. Because in the brutal economy of infantry combat, rate of fire was everything. It determined how much ground you could suppress. It determined how long it took to reload and how long that window of opportunity lasted. It determined whether a defensive position held or broke. And in the experience of Allied soldiers, it determined whether the sound they heard was manageable or absolutely terrifying. If you want more content like this, subscribe right now. More is coming, and you do not want to miss it. Let's start at the bottom of the list, with the machine guns that were slow by German standards. And here is the first thing you need to understand. Slow by German standards was still fast by almost anyone else's standards. The baseline for what counted as a machine gun in World War II was roughly 300 to 500 rounds per minute for most nations. The Soviet Maxim, the American Browning, the British Bren, these were all in that range. Reliable, effective, respected weapons. But when German machine guns entered the equation, that baseline suddenly looked almost quaint. The first weapon we need to talk about is one that most people have completely forgotten: the Drace Model 1918, often called the MG-13 in its interwar updated form. This was a weapon born in the last years of World War I, carried over into the Weimar Republic era, and still in limited service during the early years of World War II. The MG-13 was chambered for the standard German 7.92 by 57mm Mauser cartridge, fed from a 25-round detachable box magazine or a 75-round saddle drum. Its rate of fire sat at approximately 600 to 650 rounds per minute. By the standards of the early 1930s, that was respectable. By the standards of what Germany was about to field later in the war, it was already obsolete before the fighting started in earnest. The MG-13 was used primarily as a light machine gun during the Spanish Civil War, where German forces in the Condor Legion got their first taste of modern mechanized conflict. It was also mounted on early German armored vehicles before being replaced by purpose-built weapons. By the time Operation Barbarossa launched in June 1941, the MG-13 had been largely phased out of frontline service and handed over to allies or secondary units. But its role in the development of German machine gun doctrine cannot be ignored. It was the bridge between the old world and the terrifying new one. What the MG-13 represented was a philosophy. Germany, unlike most other nations, did not design machine guns to be heavy, defensive, crew-served weapons that stayed in fixed positions and supported the infantry from behind. Germany designed machine guns to be the centerpiece of the infantry squad. The machine gun was not a support weapon in German doctrine. It was the primary weapon. The rifleman existed to support the machine gun. That inversion of priorities changed everything. And it meant that even a relatively modest weapon like the MG-13 was being used in ways that other armies had not yet conceptualized. 650 rounds per minute. Remember that number, because from here, the numbers only go up. Next, we need to talk about the MG-08, the weapon that Germany inherited from World War I and still had in service during World War II. Yes, you read that correctly. The MG-08, a weapon designed in 1908, based on Hiram Maxim's original 1884 design, was still being used by German forces in the early years of World War II, primarily in static defensive positions, fortifications, and second-line units. This was the classic water-cooled, belt-fed heavy machine gun that had turned the Western Front into a killing ground a generation earlier. The MG-08 fired at approximately 300 to 450 rounds per minute, depending on configuration and condition. By 1939 standards, that rate of fire was genuinely slow. But the MG-08 had something that made it valuable in certain contexts, despite its age. It was extraordinarily accurate at range. It could sustain fire almost indefinitely thanks to its water cooling system, and it was built with a robustness that meant it simply would not break down easily. Fortifications along the Atlantic Wall, older defensive lines, and second echelon positions often used the MG-08 precisely because it was reliable, available in large numbers, and did not require the same logistical chain as newer weapons. The MG-08 also spawned a lighter variant called the MG-08/15, which, despite the name, was not a light machine gun in any practical sense. It weighed over 18 kilograms when loaded, and equipped with its drum magazine. The 08/15 was an attempt to make the Maxim design more mobile, and it partially succeeded in World War I, but by World War II it was an anachronism being used out of necessity, not preference. What matters about the MG-08 for our purposes is what it represents in contrast to what came after it. Because when you understand how slow this weapon was, how heavy, how cumbersome, and how logistically demanding with its water cooling requirement, you begin to understand just how revolutionary the weapons Germany developed in the 1930s truly were. The MG-08 was a weapon of attrition. What came next was something entirely different. Now we move into weapons that began to define the German approach at a new level. The MG-15 and MG-17 were aircraft machine guns that sometimes found secondary use in ground roles, particularly late in the war when German forces were improvising and using whatever was available. The MG-15 was a flexible defensive gun used in bomber aircraft, firing at approximately 900 rounds per minute. The MG-17 was a synchronized weapon for fighter aircraft, firing at approximately 1,150 rounds per minute. These are worth mentioning not because they were primary infantry weapons, but because they illustrate the broader German engineering mindset during this period. The goal was always higher velocity, higher rate of fire, more suppression, more lethality. When aircraft were shot down or stripped of their weapons for ground mounting, these guns occasionally ended up in improvised anti-aircraft or defensive positions. Their high rate of fire made them useful in that role, even if they were not designed for it. And they point towards something important. Germany was pushing the boundaries of what a machine gun could be in every domain, air and ground alike, simultaneously. The engineering culture that produced these aircraft weapons was the same culture that produced what most people consider the greatest machine gun ever built. Let us talk about the MG-34. If there is a moment when German machine gun technology made a quantum leap, it was 1934, when Mauser's engineers, working from a competition to create Germany's next universal machine gun, delivered something that the world had never seen before: the Maschinengewehr 34. This was the weapon that embodied the German concept of the Einheitsmaschinengewehr, the universal machine gun. One weapon that could serve as a light machine gun with a bipod, a medium machine gun on a sustained fire tripod, a coaxial weapon in armored vehicles, an anti-aircraft weapon on a specialized mount, and a weapon that could be operated by a single soldier or a full crew depending on the tactical situation. The MG-34 fired at approximately 800 to 900 rounds per minute. In 1934, this was extraordinary. The American Browning M1919 fired at around 450 to 600 rounds per minute. The British Bren fired at around 500 rounds per minute. The Soviet Maxim at around 5 to 600 rounds per minute. The MG-34 was firing at nearly twice the cyclic rate of some of its contemporaries. And it was doing so from a weapon that weighed just over 12 kilograms in its basic light machine gun configuration. Portable, versatile, and delivering fire at a rate that simply had no equivalent anywhere else in the world at that time. The feed system of the MG-34 was another engineering marvel. It could accept both a 50-round belt or a 75-round saddle drum magazine, and switching between them required almost no tools. The barrel could be changed in under 10 seconds by a trained crew, which was critical because at 800 to 900 rounds per minute, the barrel heated rapidly and needed to be swapped to maintain effectiveness. The quick-change barrel was not a new idea, but the speed and simplicity with which it could be done on the MG-34 was unprecedented. The weapon also had a dual trigger system. The upper trigger fired semi-automatic, one shot per trigger press, while the lower trigger fired full automatic. This gave the gunner a level of fire control that other machine guns simply did not offer. In situations where precise fire at individual targets was needed, the semi-automatic mode conserved ammunition and reduced heat buildup. When suppression was required, the full automatic trigger transformed the weapon into something that could dominate an entire field of fire. Ammunition for the MG34 was fed in belts that could be linked together, creating sustained fire capability that was limited primarily by ammunition supply and barrel temperature rather than magazine capacity. A well-supplied MG34 team could generate almost continuous fire for extended periods, cycling through barrel changes with practiced efficiency. In the early years of the war, during the campaigns in Poland, France, the Low Countries, Yugoslavia, and the early stages of the Soviet campaign, the MG34 was essentially without peer as an infantry support weapon. Allied forces who encountered the MG34 for the first time in France in 1940 were genuinely shocked. British and French troops trained to advance in formations designed around the suppressive fire rates of their own weapons suddenly found that those formations were catastrophically wrong when facing a weapon that could deliver twice the volume of fire at twice the speed. Entire tactical manuals had to be rewritten. The distances at which infantry needed to disperse, the timings of their movement between cover, the way they used smoke and indirect fire to suppress German positions, all of it had to change. But the MG34, for all its brilliance, had a critical weakness. It was expensive to produce. The tolerances required to achieve its smooth operation were extremely tight. The machining required was complex, time-consuming, and demanded skilled labor at a time when Germany was rapidly expanding its military production. An MG34 took approximately 49 kilograms of raw steel and roughly 150 man-hours to produce. As the war expanded and Germany needed machine guns in vastly greater numbers, this became an increasingly serious problem. The weapon was simply too refined, too complex, and too expensive to mass-produce fast enough. And so Germany went back to the drawing board. And what came out of that process was something that, in the words of many military historians, may be the single most influential small arms design of the 20th century, the MG42. If you have watched any documentary about World War II, if you have played any game set in that conflict, if you have read any memoir from a soldier who served on the Western or Eastern Front, you have encountered the MG42. Its reputation precedes it so thoroughly that even people with no interest in firearms history know its name. But knowing the name and truly understanding what this weapon was and what it represented are very different things. The development of the MG42 began in the late 1930s as a response to the MG34's production problems. The engineering brief was essentially this: build a machine gun that is as effective or more effective than the MG34, and that can be produced faster, cheaper, and by less skilled workers. The challenge was accepted by Grossfuss AG, a company that had previously specialized in sheet metal fabrication, which turned out to be precisely the right background for what was needed. The MG42 was revolutionary, not primarily because of its fire rate, though we will get to that in a moment. It was revolutionary because of how it was built. Where the MG34 was machined from solid steel with high precision, the MG42 was built around stamped sheet metal components. The receiver was stamped. Many of the secondary components were stamped. The barrel shroud was stamped and perforated, not only saving material, but improving airflow for cooling. This approach reduced manufacturing time dramatically. The MG42 required approximately 75 man-hours to produce, compared to 150 for the MG34. It used approximately 27 kilograms of raw steel compared to 49. It was half the production effort for a weapon that was arguably superior in the field. But then, there is the rate of fire, because this is where the MG42 entered a category that it essentially owns to this day. The MG42 fired at approximately 1,200 rounds per minute in standard configuration. Some well-maintained examples with favorable conditions achieved rates closer to 1,500 rounds per minute. At 1,200 rounds per minute, the MG42 was firing 20 rounds per second. 20 individual bullets leaving the barrel every single second. At that speed, the human ear cannot distinguish individual shots. What you hear is a single, continuous, mechanical tone. Soldiers compared it to the sound of ripping fabric, tearing canvas, a zipper being pulled across the sky. The Germans called it the Hitlersäge, which translates roughly to Hitler's buzzsaw. Allied soldiers had their own names for it. The British called it the Spandau, in reference to older German weapons, but the term became associated with the MG42 specifically. American soldiers simply called it the buzzsaw, and every name in every language captured the same essential quality. This weapon did not sound like a gun. It sounded like something mechanical and inhuman had been pointed at you and switched on. The psychological effect was profound and documented extensively in Allied after-action reports and veterans' testimonies. The sound of an MG42 opening fire had an immediate and measurable effect on the behavior of Allied troops. Men who had maintained composure under fire from rifles and slower weapons would involuntarily seek cover, sometimes freezing, sometimes moving to cover when staying in position would have been tactically better. The sheer volume and speed of the sound created what military psychologists would later call an involuntary threat response. It bypassed rational decision-making and triggered something more primal. The United States Army actually produced training films specifically designed to desensitize soldiers to the sound of the MG42. These films played recordings of the weapon firing and instructed soldiers on what they were hearing and why it was important not to react irrationally to the sound. The Army recognized that the psychological impact of the MG42 was itself a tactical problem that needed to be addressed through training. That is how significant the weapon's effect was. But the MG42 was not just noise. Its practical effect at 1,200 rounds per minute was devastating. In the time it took an Allied soldier to move from one position of cover to another, perhaps 2 to 3 seconds of exposure, the MG42 had put 24 to 60 rounds through the space he had just crossed. The statistical likelihood of being hit during even brief exposure in the cone of fire was dramatically higher than against slower weapons. Infantry tactics that worked against 600 round per minute weapons did not work against 1,200 round per minute weapons. The math was simply different. The MG42 used the same 7.92 by 57 mm Mauser cartridge as other German weapons, and was belt-fed using the same belts as the MG34. The quick-change barrel system was retained, and actually improved, allowing an experienced gunner to swap barrels in 6 to 8 seconds, even faster than the MG34. This was critical because at 1,200 rounds per minute, the barrel heated to dangerous temperatures very quickly, typically requiring a change after approximately 300 rounds of sustained fire. The weapon was deployed in the same universal role as the MG34, which it was designed to replace, though in practice both weapons served side by side for the remainder of the war. The MG42 was used as a light machine gun with bipod at the squad level, as a sustained fire weapon on the Lafette 42 tripod at the platoon and company level, as a vehicle-mounted weapon on armored cars, half-tracks, and tanks, and as an anti-aircraft weapon on specialized ring mounts. The sustained fire tripod, the Lafette 42, deserves special mention because it transformed the MG42 into something even more formidable. The Lafette 42 was an engineering achievement in its own right. It included an anti-aircraft adapter, a traversing and elevating mechanism of exceptional smoothness, an optical sight mount, and most remarkably, a mechanical buffer system that reduced felt recoil and allowed the weapon to maintain a steadier point of aim during sustained fire than almost any other contemporary weapon. An MG42 on the Lafette 42 in the sustained fire role, crewed by a trained team with an adequate ammunition supply, could deliver fire across a predetermined kill zone with a consistency and lethality that made frontal assault almost suicidal. During the battles in Italy, Allied troops encountered German defensive positions built around MG42 teams on Lafette tripods, and the casualty rates in frontal assaults against these positions were catastrophic. The Battle of Monte Cassino, one of the bloodiest engagements of the Italian campaign, involved precisely this kind of defensive fire. German MG42 teams in prepared positions on the Lafette tripod held off multiple assaults by numerically superior Allied forces for months. The terrain favored the defender, certainly, but the weapon made the defense exponentially more effective. At Normandy on June 6, 1944, American forces landing at Omaha Beach encountered MG42 positions that had been carefully sighted to cover the beach from enfilading positions. The soldiers who landed in those sectors faced MG42 fire at 1,200 rounds per minute, crossing open sand with no cover. The casualty rates in the first wave at Omaha were among the highest of any Allied assault in the entire war. Survivors' accounts almost universally mention the sound and the volume of fire. Not rifles, not artillery, but the continuous mechanical ripping of the MG42. Production of the MG42 eventually reached over 700,000 units by the end of the war. It was produced at multiple facilities across German-controlled Europe, and its simplified manufacturing made it possible to maintain production even as Allied bombing degraded Germany's industrial capacity. Even in the final months of the war, with raw materials scarce and factories partially destroyed, Germany was still producing MG42s in significant numbers. The legacy of the MG42 extends far beyond World War II. After the war, West Germany adopted a slightly modified version, chambered for the NATO standard 7.62 by 51 mm cartridge, designated the MG3. The MG3 remained in service with the Bundeswehr, Germany's post-war military, into the 21st century. Variants and derivatives were adopted by dozens of other nations. The core operating system of the MG42, its roller-delayed blowback mechanism, and its general layout, influenced virtually every belt-fed machine gun designed in the decades after the war. When modern weapons designers sit down to design a new machine gun, they are in some sense still working in the shadow of the MG42. But we are not done yet. Because while the MG34 and MG42 are the most famous, there are other weapons in the German arsenal that deserve their place in this story. Weapons that are less well known but that played important roles, weapons that represent different approaches to the same fundamental problem, and weapons that tell us something about how Germany adapted as the war turned against them. Let us talk about the MG81. This was a weapon designed for aircraft, used as a flexible defensive gun in German bombers and reconnaissance aircraft. Developed by Mauser in the late 1930s, the MG81 fired at approximately 1,600 rounds per minute, and in its twin-gun configuration known as the MG81Z, the combined rate of fire reached approximately 3,200 rounds per minute. 3,200 rounds per minute. That is over 50 rounds per second from a twin mount. This number exists in a realm that is genuinely difficult to conceptualize in human terms. The MG81 was designed primarily to give German aircraft gunners the ability to compensate for the high closing speeds of modern aerial combat. When two aircraft are approaching each other at combined speeds of 600 or more kilometers per hour, the window of time in which a defensive gunner can engage an attacker is measured in fractions of a second. A gun that fires at 300 rounds per minute puts 3 or 4 rounds in that window. A gun that fires at 1,600 rounds per minute puts 13 or 14 rounds in that window. The mathematics of aerial gunnery demanded extreme rates of fire, and the MG81 delivered them. While primarily an aircraft weapon, the MG81 occasionally appeared in improvised ground mounts as the war progressed, and Germany increasingly found itself improvising. Anti-aircraft positions using the MG81Z twin mount were genuinely terrifying to attack from the air, as the combined rate of fire created a density of projectiles in a given volume of airspace that was extremely difficult for attacking aircraft to survive. The physics of interception that made it valuable in the air also made it valuable against low-flying aircraft in the ground role. The MG81 used the same 7.92 by 57 mm Mauser cartridge as the ground-based weapons, but in a disintegrating link belt specific to the aircraft application. It was lighter than the MG34 and MG42, optimized for weight savings in the airframe context, but this made it somewhat less robust for sustained ground use. What the MG81 tells us is that German machine gun engineering was not a single track. It was a parallel development across multiple domains, with ideas crossing over between aircraft and infantry applications in both directions. The high rate of fire achieved in the MG81 influenced thinking about ground-based weapons, and the feed system innovations from ground weapons influenced aircraft gun design. Now let us talk about a weapon that represents Germany's response to a very specific tactical problem, the MG45. Late in the war, as resources became even more constrained, German engineers at Mauser developed an evolution of the MG42 concept that pushed the rate of fire even higher. The MG45 used a simplified blowback operating system rather than the roller-delayed recoil of the MG42, which reduced production costs and complexity even further. The result was a weapon that fired at approximately 1,800 rounds per minute. 1,800, 30 rounds per second. The MG45 was produced in only limited numbers before the end of the war and never entered wide service. But its existence tells us something important. Even in the final desperate months of the conflict, German engineers were not trying to slow down or simplify their way to a less effective weapon. They were still pushing for higher rates of fire, still believing that more rounds per minute translated directly to more tactical effectiveness. The war ended before the MG45 could be deployed in significant numbers, but the design lived on. Elements of it influenced post-war developments, and the fundamental approach of using delayed blowback with stamped components became a template for machine gun design for decades afterward. 1,800 rounds per minute from a weapon that could be produced faster and cheaper than the MG42 it was meant to replace. Had the war continued, this weapon could have made an already terrifying situation considerably worse for Allied forces. Let us now step back from individual weapons for a moment and talk about something that all these numbers and specifications cannot fully capture. Let us talk about what it was actually like to be on the receiving end of this. The Germans understood something about infantry combat that other armies were slower to grasp. They understood that in modern combat, the primary purpose of most of your firepower is not to kill the enemy directly. It is to prevent the enemy from moving. Suppression, the ability to force the enemy to stay in cover, to prevent them from shifting position, reinforcing weak points, outflanking your position, or simply advancing. Suppression is what buys time. Suppression is what allows your own forces to maneuver. Suppression, applied effectively, can be as decisive as accurate fire. And suppression requires sustained, high-volume fire. The faster your weapon fires, the more effectively you can suppress a given area with fewer weapons. An MG42 firing at 1,200 rounds per minute can suppress a section of ground that would require 3 or 4 weapons firing at 400 rounds per minute to cover equally. This means that one German MG42 team could effectively pin down a unit that would require multiple Allied machine gun teams to pin equivalently. The tactical leverage was extraordinary. German infantry doctrine built everything around this reality. A German infantry squad of 10 men was organized around the machine gun team. The MG42 gunner and his assistant were the core. The remaining riflemen existed primarily to protect the machine gun team, carry ammunition for it, and exploit the gaps in enemy defenses that it created. When the German squad moved, it moved to support the machine gun, not the other way around. This was fundamentally different from Allied infantry doctrine, where the machine gun was one element among several rather than the central element. The effect of this doctrine, combined with the MG42's extraordinary rate of fire, was that a German squad could generate a volume of suppressive fire comparable to a much larger Allied unit. German positions that appeared lightly held were often genuinely difficult to overrun because even a small number of MG42 teams could generate fire dense enough to stop a much larger force in the open. Allied commanders repeatedly encountered this situation and repeatedly had to develop responses to it. The answer was almost always the same: indirect fire, smoke, flanking rather than frontal assault, artillery preparation before infantry advance, and close coordination between infantry and supporting arms. All of these adaptations were in large part driven by the need to deal with German machine gun fire. The MG42 did not just change the experience of combat, it changed how wars were planned and executed at every level, from the squad to the division. There is another weapon we need to discuss, one that sits in an interesting place in this story, because it represents Germany reaching back to captured equipment and enemy designs to supplement its own production. The MG26T, the MG30T, and other captured weapons used under German designation tell us something about just how important machine gun capability was in German thinking. When Germany occupied Czechoslovakia in 1939, it inherited one of Europe's finest small arms industries. The ZBVZ.26 and ZBVZ-30 Czech light machine guns of excellent design were immediately pressed into German service under their own designations. These weapons fired at approximately 500 to 600 rounds per minute, well below German domestic designs, but they were available, they were reliable, and they used ammunition that could be supplied from existing stocks. Germany similarly pressed into service captured Polish, French, Soviet, Belgian, and other machine guns throughout the war. The sheer diversity of weapons in German service by 1943 and 1944 created significant logistical headaches, but the underlying principle was consistent. Machine gun firepower was so important to German tactical doctrine that having captured and foreign weapons of varying quality was better than not having enough machine guns at all. This tells us something about how central machine gun fire was to the German way of war. It was not one tool among many, it was the tool, and everything else was built around it. Let us now bring all of this together with a proper ranking, not just by numbers, but by the combination of rate of fire and actual tactical and historical impact. Starting at the foundation of the list, the MG08 and its variants occupy the lowest position not because they were bad weapons, but because 300 to 450 rounds per minute, even in 1939, was a rate of fire that reflected a World War I design philosophy. The MG08 was reliable, accurate, and still useful in fixed defensive positions. It was not dead weight in the German arsenal, but it was a weapon from another era, used out of necessity, in an era defined by something entirely different. The men who faced it were not afraid of the MG08 the way they would learn to be afraid of what came next. The MG13, with its 600 to 650 rounds per minute, represents the transitional moment. It was genuinely modern for its time of introduction, capable of being used in a light machine gun role with reasonable mobility, and it pointed toward the universal machine gun concept that Germany was developing. But it was also already being replaced before the war started in earnest, and its legacy is primarily as a stepping stone rather than a decisive weapon in its own right. Captured foreign weapons, the ZB variants, the various French and Soviet weapons pressed into service, fall in the middle of the rate of fire range, generally between 500 and 800 rounds per minute depending on type. They were useful, they supplemented German firepower at critical moments, but they were not the weapons that defined the German machine gun experience. The MG34 moves to a significantly higher position. 800 to 900 rounds per minute in 1934 was genuinely revolutionary. The weapon that had no true peer when it was introduced, that forced Allied planners to rethink their entire approach to infantry tactics, that established the concept of the universal machine gun in a form that still influences military doctrine today. The MG34 was not replaced by the MG42 because it was inadequate. It was replaced because it was too expensive and too time-consuming to produce. In terms of pure mechanical quality and engineering sophistication, many who used both weapons considered the MG34 superior in feel and precision. It simply could not be made fast enough. The MG81 in its single configuration at approximately 1,600 rounds per minute, and the MG81Z in its twin configuration at approximately 3,200 rounds per minute, represent the extreme of what German machine gun engineering achieved in the aircraft domain. These numbers are almost surreal in the context of small arms. 1,600 rounds per minute from a weapon light enough to be carried by one person in an aircraft turret. 3,200 rounds per minute from a twin mount that turned an aircraft into something approaching a flying spray of lead. These weapons were primarily aircraft weapons, but their existence and the technology they represented shaped the entire trajectory of German machine gun development. The MG45 at approximately 1,800 rounds per minute sits in a remarkable position. It was the most advanced ground machine gun Germany produced, in terms of rate of fire, combining the lessons of everything that came before it, with further simplification of production and an even higher cyclic rate. Had it been produced in numbers and deployed widely, it would have presented Allied forces with something even worse than the MG42. The fact that it appeared too late to change the outcome of the war does not diminish what it represented as an engineering achievement. And then, sitting at the center of everything, the weapon that defines this entire story is the MG42. 1,200 rounds per minute in standard configuration, up to 1,500 in optimized conditions, 700,000 produced, deployed on every front, in every role, against every Allied army. The weapon that changed how soldiers moved, how commanders planned, and how veterans remembered the war. The weapon whose sound became the defining acoustic experience of World War II ground combat. The weapon whose design is still in active service in modified form 80 years after it was first introduced. The weapon that made grown men involuntarily freeze at the sound of a mechanical zipper being pulled across a hillside. 1,200 rounds per minute. 20 rounds per second. In the 2 to 3 seconds it takes a soldier to cross from one piece of cover to the next, an MG42 had sent 40 to 60 rounds through that space. The mathematics of survival under MG42 fire were brutal and unforgiving, and every Allied soldier who served in any theater where German forces operated understood, at some level, that the machine gun was the thing. Not the Panzer, not the artillery, not the Stuka. The thing they really had to solve was the machine gun. Because you could hear a tank from a long way off, you could hear artillery incoming. But the MG42 was on you before you fully processed what you were hearing. That sound was the last thing many men heard. It is worth spending a moment on the human side of this story, because behind every one of these weapons was a crew, a gunner, an assistant gunner, ammunition bearers. Young men, most of them, who had been trained in a system that placed the machine gun at the center of everything, who had practiced barrel changes until they could do them without thinking, who had learned to read the ground for firing positions, to calculate fields of fire, to understand the sectors their weapon needed to cover, and how to coordinate with other weapons to create interlocking fields that left no ground uncovered. German machine gun crews were extensively trained because the doctrine demanded it. The MG-42 at 1,200 rounds per minute consumed ammunition at a ferocious rate. A 300-round belt lasted 15 seconds of continuous fire. Sustained suppression required smooth coordination between the gunner controlling the trigger and the assistant managing belts, watching for jams, and monitoring barrel temperature. The barrel changes that sound so simple in technical descriptions were something that had to be practiced dozens of times under simulated stress before they became reliable under actual combat stress. A fumbled barrel change, fingers burned on a hot barrel, a misaligned replacement barrel that would not seat properly, any of these could transform the decisive weapon of the defensive position into a liability. And then there was the ammunition. At 1,200 rounds per minute, an MG-42 in heavy combat could consume thousands of rounds in a single engagement. The logistics chain that fed these weapons was a military operation in itself. Ammunition bearers carrying belt containers forward under fire. Supply teams moving at night with ammunition resupply. Vehicles dedicated to machine gun ammunition transport at the unit level. The entire infrastructure of a German infantry position was organized around keeping the machine gun fed. When the ammunition ran out, or when the barrel wore out beyond reliable replacement, or when the crew was killed or wounded, the defensive position collapsed rapidly. Allied commanders learned to identify machine gun positions not just to neutralize the gun, but to target the crew. A dead gunner or assistant gunner was potentially more damaging than a destroyed gun, because guns could sometimes be repaired or replaced, while the trained crew could not be replaced instantly. Snipers specifically tasked with engaging machine gun crews became an important part of Allied tactics, particularly in the hedgerow country of Normandy and the mountain terrain of Italy. The Eastern Front presented its own set of challenges for German machine gun crews. The sheer scale of the front meant that machine gun teams were often spread thinner than doctrine intended, covering larger sectors with less support. The Soviet Army, learning from its catastrophic early losses, developed its own adaptations to German machine gun fire. Soviet assault tactics increasingly involved brief, violent rushes by small groups, timed to exploit the moments when MG-42 crews were changing belts or barrels. Soviet forces learned to use their own substantial artillery resources to neutralize German machine gun positions before infantry advanced. And Soviet snipers, some of the finest in the world, became expert at identifying and engaging German machine gun crews. The winter conditions of the Eastern Front created additional problems. At extremely low temperatures, the MG-42's mechanism required special lubricants that were not always available, and even with proper lubricants, metal contracted in ways that affected timing and function. A weapon performing at 1,200 rounds per minute in mild European weather might drop to 800 or 900 rounds per minute in Russian winter. Still extraordinarily fast, but notable. German ordnance teams worked continuously to develop cold weather solutions, but the scale of the Eastern Front meant that problems often outpaced solutions. In North Africa, the opposite problem arose. Sand and dust infiltrated everything. The fine tolerances of the MG-42's mechanism made it somewhat more sensitive to contamination than the MG-34, whose design had slightly larger clearances. German crews in North Africa developed elaborate cleaning routines and protective covers for their weapons when not in use. Despite these challenges, the MG-42 remained effective in the desert environment, and Allied troops in the Western Desert developed the same fear of it that their counterparts elsewhere had. The Pacific theater of the war is sometimes discussed as if it existed in isolation from European weapons technology, but there are relevant connections. American troops who had served in the Pacific against Japanese machine guns and then transferred to the European theater reported a genuine shock at the difference. Japanese machine guns were effective and well deployed, but their rates of fire were generally in the 500 to 600 rounds per minute range. Nothing in the Pacific had prepared American soldiers for the MG-42. The transition required a fundamental reset in how soldiers moved, covered each other, and thought about exposure to enemy fire. One of the most striking testimonies about the MG-42 comes not from a combat soldier, but from a military medical officer who served in Italy. He noted that among soldiers who had been exposed to MG42 fire, the pattern of wounds was distinctive. Unlike rifle fire, which produced individual wounds at unpredictable intervals, MG42 fire at 1,200 rounds per minute produced multiple wounds in extremely rapid succession, effectively treating the human body as something to be saturated rather than aimed at individually. The lethality per engagement was dramatically higher than rifle fire, and the shock response among survivors who had been near but not directly hit was often severe even in the absence of physical injury. The sheer volume of fire passing through a space created a physical and psychological environment unlike anything slower weapons produced. This brings us to something that is rarely discussed directly, but that shaped the entire Allied approach to dealing with German machine gun fire. The problem of suppression had to be inverted. Normally, you suppress the enemy so you can move. Against German machine gun positions, you had to find ways to create even momentary gaps in the suppression being applied to you before anyone could move. This required coordinating multiple fire sources: rifle fire, light machine gun fire, mortar fire, sometimes artillery, all converging on the German position simultaneously to create a brief window of reduced enemy fire during which the infantry could advance. These were complex coordinated actions that had to be planned and executed under fire, often by small unit leaders who had to think through multiple timings simultaneously while themselves under stress. The demand this placed on Allied junior leadership, the non-commissioned officers and junior officers who had to orchestrate these mini-operations at the squad and platoon level, was enormous, and it was driven almost entirely by the need to deal with one weapon. The MG42 did not just terrorize individual soldiers. It imposed demands on Allied leadership at every level, from the individual soldier who had to control his fear response to the platoon commander who had to plan coordinated suppression while taking casualties. The German soldier with an MG42, properly positioned and supplied, was a force multiplier of a kind that the 20th century had not previously seen in such portable and